Okay, let's find area of an ellipse. First, let's make a quick sketch. Okay, this is going to be y-axis, x-axis. This is point 0. This point is going to be point A, and this distance is A. And let's put a point B. This distance is B. This distance A and this distance A, and those are major axes. This distance is B and this distance is B. Those are minor axes. And equation of ellipse is x squared over a squared plus y squared over b squared equals 1. And we need to find area of an ellipse. Our game plan is to find this area. We just need to find this area and multiply it by 4, and we get total area. To find this area, we need to know this function. When we know this function, we just take integral between 0 and a, and this integral gives us this area. Okay, so let's find this function. We're going to use this equation, and we need to solve it for y. Okay, let's multiply it by a squared b squared. This term becomes x squared b squared because a squared and a squared cancels out, plus this term becomes y squared a squared because b squared and b squared cancels out, and 1 multiplied by a squared b squared equals a squared b squared. Okay, now let's leave this term on this side. Y squared a squared equals, and let's move this term to this side. So we have a squared b squared. When you move this term, becomes negative minus x squared b squared. Now to solve for y squared, we need to divide both sides by a squared. So we get a squared b squared minus x squared b squared divide by this a squared. Next step, let's factor out b squared, and we get a squared minus x squared divided by a squared, and let's just write it like this. It's same thing, we can just write it like this, b squared over a squared, and we can write this thing over here, a squared minus x squared. Now we need to solve it for y, so we're going to take a square root of both sides, and when you take square root of even power, we need to put plus minus. And when you take square root of this side, square root of this part becomes b over a, and square root of this part is just square root of this a squared minus x squared. Okay, I'll explain you how this equation works. Let me erase this part. Okay, so this is a function we find out, and I'll explain how it works. So this function has two branches. Positive branch, which is ba square root a squared minus x squared, and it has negative branch minus ba square root a squared minus x squared. So positive branch is this function. This positive branch gives us this function, and this negative branch is this function. Okay, to find area we don't really care about this bottom function, all we care is this upper function because we're interested in this area. And so we do not need this anymore, and we don't need this anymore. All we care is a upper function, and we just set up integral between 0 and a, and we find this area. So let's set up an integral. It's going to be integral of this function. So there you go, this is our function, b over a square root a squared minus x squared. That's integral with respect to x, so we need to write dx. And we want to integrate this function between 0 and a, so those are our limits of integration between 0 and a. That's it, all we have to do is just calculate this integral, and it gives us this area. So let's do it. First thing we can do is factor out b over a, because it's just a constant. Factor it out, and have this 0a square root of a squared minus x squared dx. Okay, to solve this integral we're going to use trig substitution, so I suggest we draw a triangle, and let's say this side x, and this is hypotenuse a, and this is going to be square root of a squared minus x squared. It's Pythagorean theorem. And let's introduce new variable. Let's introduce new variable theta, and we can write ratio sine theta equals x opposite over hypotenuse x over a. And then if you solve it for x, we can get x equals a times sine theta. And let's differentiate this with respect to theta, and we get dx d theta equals, this is just a constant a, so we just write this constant. And what's the derivative of sine theta? Let's see, derivative of sine theta is cosine theta. Cosine theta. And now let's solve it for dx. Dx equals a cos theta multiplied by d theta. Okay, and now let's do substitution. I'm going to erase this. Okay, let's use those things and just substitute into our integral. So we have this constant be a, and it's integral 0 a square root of a squared minus, okay, this x, we have it here. We're going to take this thing and substitute it here. So we get, take this thing, a sine theta. When you substitute into x, there is also exponent square. So substitute here, and dx, our dx is a cos theta d theta. Alright, that's how we do substitution. And let's erase this. Let's simplify this integral. So we have BA outside. A squared. We need to distribute this exponent here, and we get minus a squared sine square theta. And here just copy this. Let's simplify it more. We factor out a squared, and we get 1 minus sine squared theta, and we have still this thing, a cos theta d theta. Okay, now let's erase this. So we have, let's keep simplifying this thing. We have b over a integral 0a. Okay, square, when you take square root of a squared is just a. And let's use a Pythagorean identity. 1 minus sine squared theta equals cosine squared theta. That's a Pythagorean identity. And when you take a square root of cosine squared theta, it's just cosine theta. Here we have a cos theta d theta. Okay, let's simplify it more. We have b a 0 a times a is a squared, cos times cos is cos squared theta d theta. And let me erase this. Okay, what you're going to do, we're gonna take this a squared, because it's just a constant, we take it up front, and when you take this constant, it's gonna cancel out with this constant. We just going to have BA left, or AB, let's write it as AB. When you take this constant here, it cancels out this constant, becomes AB 0 a cos squared theta d theta. Okay, let's to evaluate this integral, let's use another trigonometric identity. we're going to use this double angle identity. Let me write it over here. I'm going to use this identity. Cos 2 theta, this double angle, equals 2 cos square theta minus 1. And we can solve it for cos squared theta, and we have this cos 2 theta. Move this -1, becomes +1, equals 2 cos square theta. Now we solve it for cos square theta. This stuff divide by 2, cos 2 theta plus 1 divide by 2. So it's just another trig identity. We're going to use it, and we substitute into here, and we get AB integral 0a. Substitute into here, and we have cos 2 theta plus 1 divide by 2, and of course d theta. Now let's erase all of this. And let's keep solving this integral. Okay. Here what we're going to do, we're going to take this 1/2, there is like 1/2, and just keep it up front because it's just a constant. So we get, take this 1/2 up front, and we get 1/2 AB integral 0a, and this stuff is left, cos 2 theta plus 1 d theta. So we did, we just took this 1/2 up front, and we get this integral. Now let's erase this. Now we need to evaluate this integral, but actually there is one more important thing we need to do. Because we change our variable to theta, and we make this substitution, we also need to change limit of integrations, because those limits are for x between 0 and a. Now we need to find new limits of integration for theta, and it's pretty easy to do. Let's find those new limits of integration. We going to do this technique. X equals a sine theta. X equals a sine theta. When x equals a sine theta, well, when x equals 0, when x equals 0, we wanna know what's theta equals to. So when x equals 0, you find what's the theta equals to. We substitute 0 for x, and let's solve this equation very quick. Divide both sides by a. 0 divided by a is just 0. This thing divided by a is sine theta. And when does sine theta equal 0? When theta equals, let's see, when when theta equals 0. And so this is how we find our new lower limit, and let's find our upper limit. When x equals a, we wanna know what theta is. So we substitute this upper limit into x and we find a new upper limit for theta. And let's solve this equation. We just divided by a both sides and we get 1 equals sine theta. And when sine theta equals 1, when theta equals, let's see, when theta equals pi over 2. Okay, so we have our new limits of integration. This lower limit is theta equals 0, still 0, and let me write 0 more nicely. 0, 0 still 0, and this upper limit we need to change it to pi over 2, so we can erase this one, and our new upper limit is pi over 2. Okay, so let's erase this, we do not need it anymore. We just need to finish solving it. This integral gives us area, so to solve this integral we need to break it into two integral cos 2 theta and integral 1, and let's solve this integral cos 2 theta separately. Let me just write it down here. Cos 2 theta d theta. And to solve this integral, we're going to use u substitution. We say u equals 2 theta, and let's differentiate it, and we get du d theta equals 2, and d theta equals du over 2. So let's make this substitution, and we get cos 2 theta is u, so we say cos u, and d theta is du over 2. We can take this 1/2 and we can factor it out up front, and we get 1/2 cos u du, and let's erase, let's just write it here, 1/2 is up front. And what is integral of cos u? What is integral of cos u? Let's see, integral of cos u is sine u. So when you take integral of cos u, it's just sine u. And I'm not going to write plus c. That's it. And then we just need to do back substitution. U is 2 theta, so we do back substitution, 1/2 sine u is 2 theta, it's 2 theta. Okay, so this integral equals to this, that's the value of this integral. so we can erase this. And okay, and let's solve this integral. We have this constant half AB, and cos to theta, this integral becomes this. We done it separately, so cos to theta, that's a value of this integral, so it becomes 1/2 sine to theta. And this integral 1, what's integral 1 is just theta plus theta. And this is definite integral between, we need to evaluate it at 0 and pi over 2. Okay, so let's erase this. Okay, so we have this constant 1/2 AB, and we evaluate this integral. So we first do our upper limit. It's 1/2 sine 2 times pi over 2 plus pi over 2. Substitute pi over 2 into theta, and then we need to subtract this stuff. 1/2 sine 2, yeah, we substitute lower limit, which is 0, sine 2 times 0 plus 0. Now we still have this constant 1/2 AB, and sine 2 and 2 cancels out, and it's just sine pi. And what is sine pi? What's the value of sine pi? Value of sine pi is 0, so it's 1/2 times 0 plus pi over 2 minus, what's sine to 0, 2 times 0, 0, what's a sine of 0? Sine of 0 is just 0, so it's 1/2 times 0, and plus 0, which just goes away. So here we have a 1/2 times 0, 0, and minus 1/2 times 0, 0. So here is just pi over 2 left in this bracket. That's the only thing that's left is pi over 2. So let me erase this. And we had pi over 2 left. So when you multiply, we get pi AB over 4, and that's it. That's value of our integral. And the very last step we need to do is just a quarter area, and find total area. We just multiply this thing by 4. So 4 times pi AB over 4. 4 and 4 cancels out, and it's pi AB. That's our answer. Total area of an ellipse is pi AB.